Hello, this is Solving Inequalities, Absolute Value Inequalities, Example 3. And here's the inequality that we have to solve. And we have to get this absolute value, x minus 5, all alone by itself, isolate it. Let's see, we've got a positive 9 here. I can subtract 9 from both sides. That leaves me with the negative absolute value of x minus 5 is greater than, let's see, I subtracted 9, so that's minus 6. And now to get rid of this negative sign, I'll just multiply both sides by negative 1 or divide by negative 1. It's the same thing. So here I'm left with the absolute value of x minus 5 is less than positive 6. And that switched, of course, because we multiplied or divided by a negative. So now that I have it all separated out, the absolute value variable expression is by itself, so I can split this in half. Either positive x minus 5 is less than 6, or else negative x minus 5 is less than 6. So working on this one by adding 5 to both sides, I'm left with x is less than, adding 5, that's 11. And here I'll distribute this negative sign to get negative x plus 5 is less than 6. Now I subtract 5 to both sides and I end up with negative x is less than 1. And when I multiply both sides by negative 1, I get x is greater than negative 1. So now I'm ready to graph this, and my key points are negative 1 and positive 11. So if x is less than 11, that's going to be an open circle on the 11, and less than is this way. X greater than negative 1 is an open circle on the negative 1, and everything this way. So because the graph ends up to be together like this between the 2 points, this is an AND condition. So I can put these two together into one compound inequality. There's the x, and start out with the lesser number, so the wide open side toward the x and the pointy side toward the negative 1, and the pointy side toward the x and the wide open side toward the 11. This is the answer. X is greater than negative 1 and x is less than 11.